we're going to take a look here. This is 2.3b. We're going to be solving equations of trig functions still, but we're going to be doing them by solving by using a square root. Okay, and so we're going to go through and work this in a second, but just want to take you back. If you take a look here, this is an Algebra 1 topic. This worksheet is from CUDA software. Free worksheet for you to look up if you wanted to look it up. There's an answer key at CUDA software for CUDA.com as well. So when I look at this, this is an Algebra 1 topic. We're just going to put a little trigonometry flair on it. But in terms of solving, all we want to do is we want to solve these problems by taking square roots. So take the square root of k, that equals to, anytime I take a square root, I get a plus and a minus. Plus and minus 76. Square root of 76. Number 2, I take the square root. I get k equals, anytime I take a square root, I get a plus and a minus. Sometimes the square root comes out to be a nice number. The square root of 16 is 4. And I know that because 16 breaks down into 4 times 4, and I'm looking for perfect squares. And that's not what we're doing. We did that earlier in the year. We're looking at the square root part here. When I get down to a problem like number 5, I'm going to subtract 8 from both sides first. I want to get the x squared by itself. Then I'm going to do the square root. I get a plus and minus the square root of 20. Just because I am a math teacher, I can't leave it that way. The square root of 20 is the square root of 4, which is 2 times the square root of 5. So you should go through and do those types of things. As you go to the back of this worksheet, the problems get a little bit harder. Subtract 1, 7v squared equals 28. And then you need to divide by 7 first. Hopefully this isn't boggling your mind where I'm getting these problems from. When I take the square root, it cancels with the squared, and I get plus and minus the square root of 4, but the square root of 4 actually is 2. And so if you want to go through and you want to do this worksheet, just to kind of remind yourself how this works, I'll give you some extra credit for going through and doing some Algebra 1 stuff. Not a ton of extra credit, not like an extra credit trig worksheet, but I'll give you a couple points if you wanted to turn that worksheet in. Well, what we're looking at is we're just going to put a little tiny bit of an extra flair on that. So I've got a similar problem here in number 1. Tangent squared is equal to 4. Well, in order to maybe see this, we may need to look at that tangent squared actually is tangent of theta squared. That's what it actually means. It's tangent twice. We use that in the simplifying the expressions ideas, but in this particular case, I want to say that tangent actually is squared. Well, that's going to work the same thing for sine squared here. So this would be sine of theta, quantity squared. Same thing for cosine, and so on. Okay, all of our trig functions are going to work that way. All right, and so when I go back to this problem, if I write it that way, I think maybe some of you are going to be able to see this without really any issues here. I've got tangent squared is equal tangent of theta quantity squared is equal to 4. So I want to get rid of that squared by taking a square root. And so then I get tangent theta is equal to plus and minus. I took a square root. The square root of 4 is 2. So I get tangent of theta equals plus and minus 2. Well, that's really two problems. That's the tangent of theta is equal to 2, and the tangent of theta is equal to negative 2. And the nice thing about the trig functions is that although I'm looking at both of those, well, the answer is really going to come out the same. When I do the tangent equal to 2 and the tangent equal to negative 2, the theta value is still going to be the same because I'm looking at a reference angle. And so that negative portion is really going to go away in terms of us plugging this into the calculator. And so if you remember, in order to actually solve this, we need to take the tangent inverse of both sides. So theta is equal to tangent inverse of 2. And then if I do tangent inverse of 2 on your calculator, you get the 63.43 degrees. Again, we're rounding to hundredths in all of these problems. And so then if you did tangent of negative 2, you get inverse tangent of negative 2. The second one here would be theta equals the inverse tangent of negative 2. That gives you a value of negative 63.43. But again, ultimately, we're looking at that value that comes back from there as being a reference angle, and so I needed to do the absolute value of that, which is 63.43 degrees. Okay, so even though there's two problems here, we really only need to look at the fact that it comes out to be a plus and minus 2, and the calculator is going to give us a reference angle on either one of them. Okay, I just wanted to show you that we're not forgetting about the minus part. Let me rewrite that. But we're not forgetting about it. It just is going to give us the same value as the positive one. All right, so I get a 63.43 degrees. Okay, now ultimately in this problem, I'm not looking for the reference angle per se. I'm looking for when does tangent equal plus and minus 2. And so if you remember back to our solving basic trig functions, tangent is positive in quadrant 1 and in quadrant 3. That's where the tangent is positive. And I found a reference angle for that positive to be 63.43. But tangent equal to the negative, tangent is negative in quadrant 2 and quadrant 4. And so my reference angle is right here, 63.43, and right here, 63.43. And so ultimately I'm instead of in the last problems where we were solving with just a positive or a negative, when I have a positive and a negative, I'm actually looking for 4 different angles here. Okay, so my answer to this problem is going to be 4 different angles. The first one is going to be this angle right here. Well, that angle right there actually is 63.43 degrees. And so that's the first one. The second one is the one that goes here. And so the second one is going to be, and you can put these all in the same answer if you wanted to. I'm going to put them in separate ones just because this is the first problem we've been doing. The second one is going to be at 180 minus 63.43, because that's going to get me this angle in green here. And so that's going to be 116.57 degrees. The third one is this one that goes all the way around here. So that third one is going to be 180 plus 63.43, which gives us 243, whoops, 0.43. And then the last one's going to be the one that goes all the way around here, which is going to be 360 minus 63.43, which is going to give us 296.57. Okay, so this is my answer, all 4 of these angles here. Okay, I want to know when does tangent equal plus and minus 2. Well, it equals plus 2 in this position and in this position, and it equals minus 2 in this position and in this position. And so when it equals plus and minus 2 is all of those positions put together. We'll go through and do another one, but ultimately this is just like any other trig thing that we've done. You need to go through and you need to kind of work the problem by yourself as we're kind of continuing here. So I'll go through and do one more. I'll start a different video though. So if you understood it after this one, you can be good to go. I'll put 2 more videos up here in order to cover all of the topics that we're doing for this portion.